tracking, tracer species that allow us to know where are the gas from the well-ventilated combustion regime, where are the gas from the early stage of the fire, and so on. And then by linear combination, we are able to estimate what concentration we have for carbon monoxide at a given time step. Then we also rely on models of effect, instantaneous or accumulative, and the simplest way is to rely on ISO 13571. And then we run thousands of evacuation scenarios, and this is maybe one of the difficult also part of this methodology, because we have to, of course, choose the population in the building as representative as it could be. I mean, here we are during a conference. People here are not the same, like if there are only students, and such evacuation part should take this into account and to include some unusual population and subpopulation into this statistical approach. With the CAP calculation and the evacuation scenario, we got exposure scenario. From those exposure scenarios, we can calculate time to complete evacuation, time to be incapacitated through FED, FEC. This for each individual of each exposed population of each fire scenario. So the determination of life expectancy has something to do with reliability. In reliability, it's how much time an item can work until it fails. So this is a field of ongoing research at LNE because some statistical tools exist right now, but they are not fitted to the fire conditions. And we have to deal with what is called right sensors data. It means people that have evacuated, they may die right after, but we have to deal with this distribution in our statistical analysis. What is important is that all this, provided you get good input data, you can first estimate the most influent parameters through, for example, the Sobel indexes. You can compare designs just comparing life expectancy, and you can also perform sensitivity analysis just to get a touch about if I change that hypothesis, what is the effect on the output. So there is no miracle. Any method has drawbacks, and this method, the hugest drawback is the representativeness of the data. And there are many data that we don't have for sure. First, on the risk analysis, as I told before, some techniques may miss low probability scenario with severe consequences. When you are building the source term, there are some assumptions. You assume that you have 3-4 stages of combustion and they are with given limits between them, transition. But in the reality, you have something that is continuous. And this part, building the source term, because you have to feed the matrices, you have to make some experiments on materials to know what they will emit as species under ventilated condition, well-ventilated condition, high flux condition, and so on. So this may be time-consuming, but you can build a database along the time. On the CFP calculation and evacuation calculation, the biggest drawback is that under a statistical approach, because of the computer power, calculating power right now, it's not possible to have a strong coupling between the models. Because when you are speaking about thousands of simulations, it's not possible to make thousands of CFD simulations to have statistical analysis. So we're obliged to get a weak coupling when we know for sure that people have an effect on fire. I mean, if we go out here and open the door, of course it changes the ventilation of the room, and if there is a fire somewhere here, it will change its course because we just are evacuating. So So this can be taken into account right now, but maybe in the future. For evacuation, the most biggest problem is the lack of reliable statistical data, and so we are drawn to rely on hypotheses. And the determination of life expectancy, the plus is that it will allow us to use statistical, even metrological approach of the thing by estimating uncertainties, estimating the sensitivity of the models. But in its current state, it relies on statistical distributions hypothesis. And the problem is that if we are not cautious with that, we will, the sensitivity analysis that we will do will not be a sensitivity analysis about the real life, but about the models, which is not exactly what we want. So, to draw some perspective about this methodology, it has a promising structure because it is very modular, and of course, each part is independent of the other one. And if you have some update in the methodology of one part of the methodology, then you can include this, and you can be up to date on each part. So risk analysis, building the HR, the hit rate and yields, the CFD calculation models of effect. If you have an improvement in the models of effect, for example, we can take this into account immediately without any change to the methodology. But it requires, right now, and this is the work we are doing right now with the statistical team at Eleni, it's mathematical consolidation because, of course, as I said, the input data is a key factor in that methodology, and what we want to avoid is to have a falsely good tool. We want to have something as reliable as possible. Thank you for your attention.
One quick question. Okay, in the interest of time, thank you.